Okay, so this is the key to section 2.2 part 4. Alright, so you're given a graph and you're asked to find certain information from this graph. Alright, now notice though that in this particular graph, this is an endpoint. That's an endpoint, so there are no arrows involved. Okay? Alright, so you want to find increasing, decreasing, constant. So remember, to determine the open intervals where the function's increasing, decreasing, or constant, you're going to read a graph from left to right. So as I go along the x-axis, your domain, so that's what you're going to put here, values from the domain that will make my function increase. Then all of a sudden it's decreasing. Then all of a sudden it's increasing, then constant, and then increasing. Okay? So from here to here, your function is increasing. So from x equal -4 to x equal -2, your function is increasing. Now remember though, you got to put your x values here, your values of the domain. So that's why you separated, or you put intervals or lines on the x-axis to denote where those intervals are. So from x equal -4 to x equal -2, my y values are increasing. F of x is increasing. So you're going to say -4 to -2. Then it's decreasing from -2 to this x value. So that x value is 3 right here. Okay, see right here. So that x value is 3. So from -2 to 3, my function is decreasing. Then it's increasing from 3 to this x value, 4. So let's go back over here now. So it's union 3 to 4. So from 3 to 4, it's increasing. Then it's constant from 4 to 5. So from 4 to 5, my function is constant. So all these y values are the same from x equal 4 to x equal 5. And then from x equal 5 to x equal 6, from 5 to 6, see this is 6 here. So from 5 to 6, my y values are increasing. So union, and then you say 5 to 6. Okay? So I had 3 open intervals where my function was increasing, 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 increasing. One where it was decreasing here, and then one where it's a constant. Okay? Alright, but notice you got to use values of your domain. So that's why we denoted the x-axis. We put lines through to separate them to open intervals. Okay, now let's talk about domain and range. Okay, so for the domain, you go along your x-axis. Now, domain and range is where you're going to use brackets or parentheses. Alright, so as I go along the x-axis, I start when x is 4. I start at this point. So that's the x value of -4. So that's a closed circle. So it'll be a bracket, -4, comma, then I'm going all the way. So notice I'm touching every point on the graph so far, every point, and then I stop here at this x value, and that x value is 6. So from -4 to 6, both of them have brackets because both of them are closed circles. That's my domain. Now the range, you go along the y-axis. So I start touching the graph here, and that y value is -8. So from bracket -8 all the way, and then I get to the highest point, which is here, and it denotes this as 5.5. So my y value is 5.5. So from 5.5 with a bracket. Okay? All right, now let's talk about this one. So this says find y when x equal 3. So when I go to x equal 3 and I locate that point, here's the point of the graph right here. So for that one, I'm going to use this point. So when x is 3, the question is what's the y value? Well, the y value is -8. So -8 goes here. All right, so here's the next question. Does a relative max occur at x equal -2? Well, here's -2. Here's the point. Okay, so we're going from increasing to decreasing. So yes, this is a relative max. So that is a relative max. Okay, now, does a relative max occur? The answer is yes. Okay, if it said what is that relative max, you would say 4.5. Okay, so is a function even, odd, or neither? Remember, a function is even if it's symmetric if it's symmetric about the y-axis. It's odd if it's symmetric about the origin. And it's neither, you say neither if it's none of these. So if you look at this remember, symmetry with respect to the y-axis is easy. So is this part of the graph when you're reflected, do you get this part back? No. Is that the same as this? No. Is symmetry with respect to the origin? In other words, is this distance, when you do this distance here, and you keep on going, and you get that point here? The answer is no. So you can say neither. Okay, neither. Okay, second one. Okay, same thing. Increasing, decreasing constant. So now this time you have arrows though. So as I go along the x-axis, my y values are increasing. Then all of a sudden they're decreasing. Then all of a sudden they're increasing. Okay. So now notice those are arrows, so it keeps on going. So I'm going from negative infinity this time. See right here, I actually started at -4. So not negative infinity because this was an end point. Here, this is not an end point. This is an arrow, so it keeps on going. So I'm going from negative infinity to x equal -2. Okay, x equal -2. And so it's increasing. So from negative infinity to -2, my function is increasing. My y values are getting larger. Then all of a sudden they're decreasing. And so they're decreasing from x equal -2 to x equal 2. So decreasing from -2 to 2. And then they're increasing again from 2 to infinity. So union 2 to infinity. And then you would say nowhere for constant. Okay? Alright, so for which values of x is f of x a relative max and then a relative min? Alright, now be careful. This is minimum, this is maximum. Okay, so here, this is a relative max. And here, this is a relative min. Okay? So the question is, what's this x value right here? So it helps to label the point. So this is -2, 16. This right here is 2, -16. So the relative maximum occurs when x is, this is minimum, so when x is 2, and then the maximum occurs when x is -2. Now the question is, find the relative minimum. So they want to know, what is that y value? The y value goes here. So the relative maximum, you got to be careful because I did have them backwards here. So the relative maximum is going to be 16, and the relative minimum is going to be -16. State the domain. Well, notice the arrows are pointing in both directions. So I am going from negative infinity to positive infinity for the domain. So every real number is going to be an x. Every real number for x is going to be part of this graph. It's going to be a point in the graph. So when x is -1 million, I get a point in the graph. When x is 1 million, I get a point in the graph. Will be way up there. Okay, the range. Notice the arrows. The arrows are pointing down. Arrows are pointing up. So again, I'm going from negative infinity to infinity. Keeps on going because of this arrow right here. This arrow just keeps on going. Okay. So again, negative infinity to infinity. All right, find f of 2. So this says find y when x equal 2. So locate x equal 2, that's here. What's the point? That's this point here. The question is, what's the y value? The y value is -16. Okay, so here, same idea. Find y when x equal -3. So -3 is here, right here. So there's the point right here. So label that point. So that's -3, I think 8. So the question is, what's the y value when x is -3? So when x is -3, my y value is 8. All right, now here, for what values of x does f of x equal 16? Now remember, f of x means the same thing as y. So the question is, where's y equals 16? Well, what I would do is I would locate this right here. Here's 16. Then locate the points on the graph that have y value 16. So there's this one, which we already knew. But there's just an also, and they see this point here is 4, 16. Okay, so there are actually 2 points on the graph where my y value is 16. There are 2 points on the graph where the y value is 16. So hence the plural here, y values. So you would say, so when x is -2, my y value is 16. So you put -2 here, comma, and then you say when x is 4, comma, 4, my y value is 16 as well. Now don't put that in parentheses, you leave it like this. Okay, so then determine if the function is even, odd, or neither. So remember, even, your function is symmetric with respect to the y-axis. Does this look like a symmetric to the y-axis? If I take this part here reflected about the y-axis, you're going to get this. The answer is no. Is it odd? Okay, so is it odd? So if I take, let's say, this point here reflected about the origin, am I going to get this point here? So remember, an odd function, when you're reflected about the origin, the x coordinates are opposites and the y coordinates are opposites. So look at this. 2, -16. Do you get a -2, +16 here? The answer is yes. Let's look at this one. 4, 16. Or are you going to get a -4, -16? The answer is yes. It's right here. Let's see. If you look at this point right here, reflected about the origin, you can get that point here. Yes. Okay. So this is an odd function. So this is odd. Okay. So it is symmetric with respect to the symmetric with respect to the origin. All right. So that's going to take care of the key to worksheet 2.2, part